Hello everyone, and welcome. Today, we're going to embark on a fascinating and practical DIY project, building a functional mini welding machine from a humble spark plug. This process demystifies a complex tool, turning everyday components into a device capable of fusing thin metals. It's a perfect blend of basic electrical principles and hands-on creativity. So, let's begin this step-by-step journey where I'll guide you through each stage with detailed explanations and important safety tips. First, we gather our core components. The heart of our device is a standard spark plug, originally designed to withstand immense heat and voltage inside an engine. It's robust. Heat-resistant electrode and insulating ceramic body make it an ideal, ready-made electrode holder for our welder. Next, we need a reliable power source. A powerful cordless drill battery, ideally 18 volts or higher like a 21 volts model, is perfect as it provides substantial direct current DC in a safe, portable package. We'll also require several lengths of stranded copper, DC electrical wire, a section of PVC pipe about 4.7 inches or 12 centimeters long for a handle, electrical tape, a metal washer, an alligator clip, a quick metal connector, and some basic tools, pliers, wire strippers, scissors, and a marker. Stage 1. Preparing the spark plug assembly. We start by modifying our spark plug. Carefully remove the ceramic contact tip and its rubber cap from the top. Now, take a short piece of wire, strip about an inch of insulation from one end, and use your fingers to separate the stranded copper core into two distinct tails. This increases the surface area for a better connection. Wrap one of these tails tightly around the spark plug's threaded metal body just below the ceramic. Twist it securely by hand, ensuring it bites into the threads for solid electrical contact. This connection will serve as one terminal. Next, we prepare the grounding electrode. Take a longer piece of wire. This will eventually become our handle lead. Strip and split its end as before. Wrap these strands firmly around the spark plug's side electrode or the metal base. A tight manual wrap is crucial here for a stable current flow during welding. For absolute safety and to prevent any accidental short circuits, we now insulate both connection points thoroughly with electrical tape. I recommend wrapping 2 solid layers. This practice, from personal experience, is a non-negotiable step for preventing shocks and ensuring durability. Stage 2. Crafting the handle. Our PVC pipe section becomes the welder's insulated handle. Mark and cut it cleanly to length. Now, we need to securely mount the spark plug assembly inside one end. You might find the fit is a bit loose. A simple trick solves this. Wrap a few layers of tissue or thin cloth around the spark plug's threaded section where it will sit inside the pipe, avoiding the wire connection points. This packing adds girth. For a permanent hold, apply a drop of fast-drying glue to this wrapping. After a brief 3-second wait for it to set, insert the spark plug into the pipe end. The friction fit, aided by the glue, will hold everything firmly, giving us a safe, insulated grip to hold during operation. Stage 3. Creating the welding rod. A welding machine needs a consumable electrode or rod. For a mini version, we can repurpose the hard carbon rod found inside a standard AA battery. A critical warning here: if this is your first time disassembling a battery, please wear safety gloves. The materials inside can be irritating. Using diagonal pliers, carefully cut a small notch in the battery's top metal casing. Then, with pliers, gently pull out the black carbon core. Wipe it clean with a tissue. To create a sharp, precise tip ideal for concentrating heat, we mount this carbon rod into the chuck of a drill. By running the drill and gently touching the rod's end to a rough surface like sandpaper or a file, we can quickly grind it to a neat point. This sharpened rod will be our welding tip. To attach it to our main assembly, we use a quick metal connector. Secure one end of the connector to the top terminal of the spark plug where the ceramic tip was, and clamp the sharpened carbon rod firmly into the other end. Stage 4. Building the power harness. Our welder needs a complete circuit. For the positive side, take a new wire and connect one end to a metal washer, wrapping it tightly. This washer will act as a contact plate. Attach it to the drill battery's positive plus terminal. On the other end of this wire, attach an alligator clip. This clip will connect to our workpiece. For the negative side, we'll use the wire already coming from our handle. At its free end, strip, split, and connect it to another metal washer. This washer will contact the battery's negative terminal. Important, always double-check your polarities. While this setup works, for some metals, reversing polarity carbon rod on positive, workpiece on negative can yield different results. Experimentation is key. The final result and the science behind it. And there you have it, a fully functional, homemade mini-arc welder. The operating principle is elegantly simple, yet powerful. When you touch a sharp carbon rod connected to one battery terminal via the spark, plugged to a metal workpiece connected to the other terminal via the alligator clip, you complete a low-voltage high-current circuit. At the point of contact, the electrical resistance is so immense that it generates intense heat enough to locally melt thin-gauge steel, copper, or other metals, fusing them together. The spark plug's role is twofold. Its metal body conducts the current perfectly, while its ceramic insulator safely contains the heat and electricity, protecting your hand in the PVC handle. This project is more than just assembly. It's a lesson in improvisation. It reminds me of a legendary story from 1970s California, where a resourceful racer named Jack Sloan, facing a broken spark plug with no spare, famously borrowed one from a film crew's generator to get his car running and finish the race. It underscores that ingenuity often trumps complexity. Once your build is complete, test it in a safe, well-ventilated area on some scrap metal. Wear safety glasses. The sight of that tiny controlled arc and the feel of metal melting under your command is incredibly satisfying. It's like harnessing a pinpoint lightning bolt. I'd love to see what you create. Share photos or videos of your mini welder and your first projects in the comments below. If you enjoyed this journey from simple parts to a powerful tool, please give this video a thumbs up and subscribe for more DIY adventures that blend creativity with practical science. Thank you for watching, and I'll see you in the next project.